Hey everybody, this is Larry. This is the last day, I think. Yep, the last day of the November Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Maximal rectangle. Okay, so given a row, columns, binary, okay. This one is actually pretty tricky. Um, eh, Yeah, I mean, I think this one is very hard. I think it requires a lot of a few components to kind of think about how to get this answer. If I remember correctly. Um, yeah, I mean, I think it's a hard problem. It's a hard solution. Uh, um, Dynamic programming. Let's see, n is 200, or r/c is 200. Yeah, this is a very hard problem. So anyway, let me first by saying then, um, I am recording this live, so because my goal here is to show you how a real engineer would attack this problem and not just give you the answer. If you want the answer, maybe fast forward, watch someone else's video. I don't, I'm not the jealous type, or whatever you need to do. But here I'm going to try to attack this one. I'm not going to lie. I do have a vague idea about this one being, DP and monostack and all this stuff. But that said, I don't remember all the details. I just remember this one being hard. And honestly, yeah, I mean, I have solved this one before, someone similar to this one before, but but this one is a tough one to kind of put everything together again, because I have to kind of reproof everything, not reproof, but reconstruct everything from first principle. So it's a little bit, I mean, this is just a tricky problem in general. If you haven't seen it before, and apparently even if you have seen it before, but if you haven't seen it in a while. Okay, so let me think about this. So the idea that I do vaguely remember, so this is an advantage I have over some of you, is that I have solved like 5,000-6,000 problems, something like that. I don't remember all of them, to be honest. Maybe even more, maybe less. I don't know. This is over also 20 something years or something. Maybe not 20 something, maybe almost 20 years, say 2001, 2002, something like that. So anyway, almost 20 years or close to 20 years. So even though that's a big number, don't be that impressed, because I think, especially nowadays, I feel like people solve a lot more much quicker. But I also feel that people kind of give up earlier and just look up the answers way quicker than I did. But that's besides the point. Okay, let's get back to the focus here. So anyway, what I was going to say is that I do have a vague idea that well, that we can brute force on one dimension, on one of the dimension, and then do something smart with the other one. I think that's the idea that I would have. Maybe there's a easier problem. I think that's my intuition with respect to maximal sum in a rectangle. But maybe there's a better solution than this, right? So, okay. Stepping back a second, right? If, let's say we brute force on the rows, right? And what I mean by brute force on the row, that means that we do something like for I in range of, let's say R is equal to the length of matrix, C is equal to the length of matrix 0, and then I remember that is, you could do something like this, and then basically now you can, okay, given this rectangle, what is the, given these two rows inclusively, what is the biggest or maximal, I guess, as they use the rectangle here. I think that's probably good enough. And then I'm trying to think. Okay, let's say we now reduce this to Okay, now let's say this works. If it works, how do we reduce the other part to a linear type thing, right? Because I think 200, what's 200 cube? 200 times 200 times 200. Yeah, 8 million. So we add a log n layer to that, it's going to be a little bit expensive. Because 2 to the what? 2 to the 8 is 256 or something like that. So that's like 64 million. That's gonna be a little bit slow. 8 million maybe is okay, depending on the test cases. So yeah, yeah. So okay. So then how do we get? I mean, I also know that there's a prefix rectangle or prefix sum to kind of calculate this way quickly. But I'm trying to figure out. Oh, I guess you could just do greedy. You could just do a scan then, right? Um, yeah, we can just do a scan real quick. Yeah, okay, that's not that bad then, right? Huh, maybe I did make it sound harder than it is. I don't know. I think that's one thing I would also say is that, to be frank, some of this quote unquote hardness, at least my perception of it being hard, is kind of like my baggage from just doing this for a long time, right? And what I mean by that is that I feel like a lot of people these days are just way good and they got good way faster and earlier than I did. And so they just kind of consider everything is like basic because they kind of start at these problems. Where for me, I didn't encounter this problem until much later in my, you know, competitive career, say. And also like I had to derive everything myself, right? There was no looking up the answer. People didn't really help, or at least people didn't help you in a way that is, you can't just Google the answer or something, right? Like I definitely had a couple of people who are very funny and very generous with their time. One of them is being Misoff. Give him a shout out. But when I was beginning, and Snapdragon was one of them. Ryan is another person. Anyway, that said, they were very generous with their time, but they also didn't like just give me the answer, right? Because that's not, I would feel bad. They would, I mean, I would feel bad about myself in that, like it's admitting defeat, and also I have some just like I don't want to bother people that much, and also they probably lose some respect for me at some point, right? So yeah. So anyway, so maybe this isn't that bad, is my point, even though I took a long way to say it. But I just have always have this conception of But let's create the prefix rectangle. And the idea behind this prefix rectangle, and I've shown this a few times, but I am going to bring up the paint thingy so that I can show you just in a really quickly what I mean, right? So let's say we have this thing, right? And am I showing on screen? There are a couple of things in the past where I wasn't showing on screen, but basically the idea is that to get so in this case, let me break it down to a few components, right? So a rectangle, let me use another color. So a rectangle is full when the area is equal to the area, right? Maybe that doesn't make sense, but for example, the area of the rectangle is 6. The sum of all the squares is 6, so therefore it's a full square. Where if you look at this, the sum of the numbers is 7, but the area is 8, so that's not a did I say square? I meant rectangle. I said square. I don't remember what I said. So basically, you have to get whether this is a full rectangle in terms of sum. And one way to do it is by using prefix sum. And prefix sum, of course, in this case, well, one is, if you're not familiar with prefix sum, practice the one-dimensional one first. And then the two-dimensional one is built off the same idea, except for if you recall, in the one-dimensional version, you get the. Let me make this line a little thicker. You get this. Let's say you want to get the sum of this segment. Well, the sum of this segment is just equal to the sum of. I'm doing it on top, but this segment minus this segment, right? So that's the idea behind prefix sum in a 10-20 second spiel. Also, speaking of spiel, I don't know when this I don't know when the timing is, but happy Hanukkah to my Jewish friends. Live in New York, so I have many Jewish friends of Jewish descent. So yeah, happy Hanukkah, and that I don't know. It's really middle of the video, so I don't know if the people are staying for that part. So maybe I'll remember tomorrow much earlier. But in any case, but yeah, but that's the thing behind this, right? So the prefix sum is okay. You have a long segment, you have a smaller segment. You subtract them to get the suffix, right? I mean, it doesn't have to be suffix, because for example, if you have here, if you have this square, well, you wouldn't take the entire rectangle because the prefix sum, you just take this rectangle minus this rectangle, right? So that's basically a 1D prefix sum. And then the 2D prefix sum is built up the same idea of, okay, let's say you want to get this, right? Well, then that is just this sum, right, from the corner minus this rectangle minus this rectangle, and of course if you minus those two rectangles, you double count this rectangle, right? So then you have to add back in that rectangle. So that's basically the idea behind this prefix rectangle, prefix sum, 2D prefix sum, if you will. So yeah, so basically that's it. And what else was I going to say about this one? Yeah, so then here my idea is going to be just basically do a brute force walk, right? Yeah, so I walk from here. I go, okay, this is my idea. We'll see if it's fast enough. It should be okay, but maybe not. So I check the first row. Okay, it's good. So then I have one rectangle, right? And then the second one, I have this one. So I try to add this one by extending it in a greedy way. Of course, this one has a 0 so I would check only this column. And of course, I have a 0. So that's going to be no Gucci. So then I kill it, right? And then the next one I look at here, it's good. And then I go on, right? Actually, and then now the way that I think about, now that I see it, I don't even need the prefix rectangle, right? I can just do a prefix, like I could just have vertical strips. And that should be good enough if I do it that way. So this is going to be all squared times c. So we'll see if it's fast enough. Naively, all squared times c is obviously 800, but it's actually all choose 2 times c. So that's going to divide it by 2. So it's roughly 4 million. Maybe that's fast enough. We'll see. But let's do the prefix sum by row, by column in this case. We can actually swap if necessary. But yeah. Okay, so then let's do that first. So for I in C, in range of C, and then now for J in range of R, we do prefix. We want to pen an empty array of 0 just for the border, and then now prefix of -1, we have pen prefix of -1, -1, plus matrix of ij, right? I think that should be okay. But basically, this is just creating the prefix sum from top to bottom, right? Let me see if this is good. So one thing that I like to do if I'm not certain about something is just print it out halfway through, so you don't have to worry about it. And of course, this is actually wrong. Do they? Oh, they give us. Why do they give us on a string? Huh? That's awkward. Okay, actually. Okay. I mean, I guess I just didn't expect it. Oh, range. Dum dum dum. The last prefix. That's weird. Because they should always have one element, right? Okay, so prefix, we add a thing, and then here we take the last element, which is just this array. Though I guess we could have written it in a different way, but then we take the last element of this array, add it to here, right? Is that weird? That should be right. I don't know. Maybe I have a typo that I'm not seeing. Is this part getting me the wrong answer? No, so it's this part. Okay, so I and oh, whoops. I used to use I and J, but then now I inverted the row instead of column. Maybe I should have done it the other way. I don't know. But yeah, but you can see that you know, for example, this is the first column, the prefix sum, so it goes 0, 1, 2, 3, 4. Wait, is my thingy still up? Oh snap! Sorry, hang on. Okay. I mean, I didn't really do much. All I did is wrote this, and then I also swapped the I and the J because I was silly, and then I try to print the array because try to verify if you have, you know, try to test your components, and you know, if you're writing production code, you might break it up into another function, but for me, this is good enough for me to kind of look, and then of course with here the output, we check whether this is what we expect, which is what we do by comparing it to this example. And this example, we go, okay, the first column, this is the prefix sum, and the second column, and that's right? Okay. So then now we should be able to do this maybe. Okay. So then basically, well, let's have a best variable. So basically, what happens, right? Okay. So, oh yeah, right. Okay. So then now we do for k in range from 0 to c minus 1. Yeah. So then now we check what column do we check in this prefix? So we check prefix sub k from I to j, maybe. Let me think about this. This may be off by 1. That's why, because basically, yeah, this is off by 1 because we have the additional 0, 1 to show that it is nothing. So here will give us, well, no, that's not how the prefix is only a 2-dimensional thing, right, Larry? So actually, what we want is this minus this. Am I having off by 1 here? Well, we want it to include I, so that means that we want to minus I minus 1. So okay, so this should be the number thing here, and this should, in theory, you go to j minus r, right? So that's actually write this here. This way we don't have to keep checking it, right? So if delta is equal to this thing, that means that the new column that we're adding is good. What happens? Well, then we can just do, let's start with total is equal to 0. If this is good, then we add delta for adding the column, and then otherwise we just set total is equal to 0. And then we do best is equal to best total, and maybe that should be good enough. What did I delete? I deleted a comment. Oh, yeah, okay. Yeah, maybe that's fine. Okay. Okay, so this looks good for this input. I did have some idea of a monostack, but maybe I'm thinking of another problem and I mixed themselves up, because this one is not that bad if this is okay. Okay, so they don't get, oh, rows and columns could be 200. Okay, fine. Then return 0. Something like that, I guess. Didn't really think that 0 would be an input, but okay, so I do get the wrong answer. For this one. Dun, dun, dun. Oh, because I did I from, so this thing means that they cannot have, maybe I'm off by 1 here. So we're gonna do I and j inclusive, so okay, fine. But then, is this right? That doesn't make sense, does it? Let's see. Let me think about this for a second. How did this get 6 correctly then? So, okay, so delta is equal to 1. I mean, it just seems like I have an off by 1 somewhere. Let's see. J plus 1. I think this should be good. C from 0. This should be good too, right? Okay, let's so basically we're wrong for this case, and probably even more cases, so so we would probably have to be a little bit careful. And this one we have wrong, this one we verify. Okay. Okay, so this doesn't even print at all because this doesn't execute. That makes sense actually. Let me think. So I think the way that I'm using J is actually an exclusive range, given that I didn't state it explicitly. Wait, is that true? Yeah, because otherwise, yeah. Huh? Did I get that wrong? That wrong though. Now I made it exclusive, but I'm not confident about this. Why should we have? Well, what's the difference between inclusive and exclusive? Well, the reason that they're different is because I'm missing one up case. But I think what I'm trying to do right now is trying to understand why that makes such a difference. I mean, I get it logically, but I get it mathematically, but I'm trying to get it logically, like trying to build an understanding in my head of why that is. Okay, so if we have an exclusive range, then the exclusive range goes to R, and R is the last. I think I'm just missing a +1 before, maybe. Why wouldn't inclusive range work? I guess I didn't do this. Maybe that's why. So if we do inclusive range, then this is the case. So yeah, I think I'm more comfortable with inclusive ranges in general. So that's why I wanted to make sure I understand it correctly, and I think that's why all the pieces were a little bit weird. Okay. But as long as you understand it, it makes it a lot easier. So this is, of course, I'm just thinking whether I should optimize, right? Because this is O of R times C, right? Roughly speaking. So if R is bigger than C, we should swap, right? But it still takes a linear cost to swap, so I don't know. What do you think? Should I swap or should I? Because writing a transpose, I think there's a shortcut for writing a transpose, but I don't know. So we want to make C the smaller one, okay? So okay, let's do it for fun. Okay. So usually I would submit first, just to get a baseline, and then when you make optimizations, you make optimizations on it. But this time I'm going to YOLO a little bit and just make the optimization. So if C is C is greater than R, then we should swap, right? Transpose of matrix. Is there an easy way to make a transpose? I don't know. Let's just do it manually for for whatever reason. So yeah. Oops. Yep. Right, and that should be good. Let's run it real quick just to make sure. Ooh. Oh, whoops. I want to run it real quick, and then what I also want to do, and this is an easy thing to test, is just take this input and then transpose it. Though it's a little bit. Oh, huh. Does this go in infinite loop somewhere or something? That doesn't make sense, right? I mean, that's the only thing that would make it happen. Oh, whoops. Okay, so that still looks good. So let's take this input and transpose it. But that's going to be actually a little bit or a lot annoying to do. So let's just do it manually then. I guess it really doesn't matter what the input is, right? Because as long as it's right. Like, it doesn't have to be exactly the same, though. Yeah. Okay, so that still looks good. So let's give it a submit. Last time apparently I had 3 wrong answers. Hopefully this one's a little bit better. Maybe time limit exceeded. Nope. Oh, well. Well, the time is much slower, but at least I got on the first go. So I am learning. I don't remember. I mean, I do remember this problem, but I think I remembered it wrong. Because this is way easier than the way that I think. But let's take a look. Maybe there's a easier solution. Because this is all. So yeah, this is all times R times C. Yeah, let's see if I can figure it out from. Oh, I did do it with a stack last time. I guess there is a monostack. I didn't really think about a monostack solution this time for whatever reason, but it's still fast enough. I did talk about it, but I guess there is an n-square solution. Today I'm not really thinking about it. Wonder why I didn't know. I mean, I think if this one had time limited exceeded, I would have done it, or I would have tried to done it with monostack. That's a recurrence that I have to try to think about. How would I? Let me think for maybe a quick minute to see how would I think about it with monostack. So clearly, I don't remember from last time. Or I have some vague recollection from last time, clearly, because I did say monostack in the beginning, but I don't remember the understanding. And I didn't really look at the code. I just saw it enough to see that I have the monostack. But so this works. Oh, I remember now. Kind of. Because I'm not. Basically, the idea is. I mean, I don't know if I remember, but is it remembering? Is it figuring it out? I don't know. Maybe at some point it's one and the same. But basically, when you're at a corner, right? You're at a cell. You have basically, monotonically speaking, something that looks like this, right? Let me use another color. Something. This isn't quite right because it doesn't whatever. But you have something that looks like. Let's pretend this is a 1 for now. Right. Let's pretend that's a 1, and then you would have something like. You have something like this, and then you have a stack, and then you have a stack, and then you keep going, right? And then the idea is kind of try to figure out from the green parts how to go backwards, and it may even be the other way. Yeah, try to go back and construct this in some way. But I don't remember how to do it, to be honest. So maybe I need to think about how to study for this later. But yeah. Well, I mean, I do have the other video in which I made 3 wrong answers. So go check that out. Today I did it in a naive way. But sometimes if it's good, then you don't need to worry about it. But yeah, it is the last problem of the month. So thanks for kind of hanging out. Thanks for chilling. I don't know. Let me know if you did it the more optimal way, which the past Larry did. Maybe today I'm just a little bit rougher. But yeah, come back for next month. We'll do all the problems again. Stay good, stay healthy, to good mental health. Of course, take care of yourself. Happy Thanksgiving, or belated Thanksgiving. Happy Hanukkah and happy holiday seasons. I'll see you later, and take care. Bye-bye.